All right, so in this video, I'll be showing you how the equation of uniformly accelerated motion, also known as the Suvat equation, is derived. So in this case, we just go straight to the point and then we're going to be proving those equations. But before I move on, one thing that needs to be known is that the equation of motion is only valid for a motion of a body in a straight line, and it's also valid for a body that is moving with constant acceleration. A sample of such body is a body moving under the influence of gravity, right? So now let's consider that a body is moving along a straight line, right, with a constant acceleration a. We take this as the acceleration, and let's assume that the initial velocity of the body at time t is equal to 0 is u. So the initial velocity is taken as u. Then after a further time t, the velocity increases to what? To v, right? So we have the foundational terms that will be used in proving it. So from definition of acceleration, we know that acceleration is what? Change in velocity. Change in velocity, right, divided by what? Divided by time. So that would now give us what? V minus u over what? T, where v in this case is the final velocity and u is the initial velocity. So I can write it like this, that a is equal to what? V minus u over what? T. So if I cross multiply, then I can say that what? V minus what? U is equal to what? AT. Then if I make v the subject of the formula in this equation, I have that v will now be equal to, if minus u comes to this side, of course it's crossing the equality sign, it will turn to positive to become AT plus what? U. So if I rearrange, I can say v will now be equal to what? U plus what? AT. So let's call this equation 1. Now note something, equation 1 here will be the foundational equation for every other equation. Now let's consider case 2, which will give us equation 2. Now if the distance traveled by the body in time t is given by what? S, and the time is given by t, then we can say that the distance of the body is the product of its average velocity and time. What do I mean? The distance moved by the body will be the product of its average velocity. So I can call this what? V bar, right, times t. Now the question is, what is the average velocity? The average velocity is the initial velocity plus the what? Final velocity divided by what? 2. So we can therefore say that the distance moved by the body is equal to what? U plus v over what? 2, right? Everything multiplied by what? T. So if I rewrite this, I can say that what? S will now be equal to u plus v, right, into bracket t over what? 2. So we can call this one equation what? Equation 2. Don't forget, I said earlier on that every other equation will take their foundation from equation 1 and equation 2, especially equation 1. So that is that. Then let's consider case 3. Case 3 will give us equation 3. We are just going to do a recall. So from equation what? 1. From equation 1, we have what? V is equal to what? U plus what? AT. So all I will just do is I will substitute equation 1. So substitute what? Equation what? 1 into what? Into equation what? 2. What does that mean? It implies that wherever I see v in equation 2, I will replace it with u plus AT. So I have what? S is equal to what? U plus v, that is u plus what? AT into bracket t over what? 2. So if I solve this further, simplify this further, I have u plus u, that is what? 2u plus what? AT into bracket t over 2. So this one is still the same thing as using t to open the bracket. That is what? 2 what? Ut, right? Then plus what? At square, then everything over 2. So from our knowledge of arithmetic, we can distribute these two to both of them. We can write this as what? 2ut divided by 2 plus what? At squared divided by what? 2. 2 cancel what? 2. So we have what? S is equal to what? Ut plus what? At squared over 2. And in most textbook, this is rendered as what? S is equal to what? Ut plus what? Half what? At squared. Half at squared is the same thing as at squared over 2. So this is equation what? 3. So that is that. Now to now determine equation 4, like I said, that will be case 4. We take our foundation from equation 1. I will still make use of equation 1. All I will just do, I will just recall again, or I will say from equation 1. Recall, right? From equation what? 1. We have that V is equal to what? U plus what? At. Right? All I just want to do now is I want to make T the subject of the formula so that I can substitute it back into equation 2. You know, I said both equation 1 and 2 will be used. So we can say that V minus what? U is equal to what? At. How do I mean? If U comes here, it becomes negative. So from that, I can divide through by the coefficient of T, which is what? A. So I can say that what? V minus U over what? Over A is equal to what? T. Or I can say T is equal to what? V minus U over what? Over A. So let me just call this equation star. Right? So I will now substitute. Now say substitute equation what? Star into equation 2. And of course, if you look at equation 2, we have S is equal to U plus V into bracket T over 2. So wherever we see T, we replace it. So let me rewrite this so that if you didn't write it earlier on. So from equation what? 2, we have what? S is equal to what? U plus V into bracket T over what? 2. So if I rewrite this, it's the same thing as saying what? U plus V, right, over 2 multiplied by what? T. So all I will just do is I will substitute the value of T here. So I will now have what? S is equal to what? U plus V, right, over what? 2 multiplied by what is T? That is V minus U, then over what? Over A. So now let's now do the mathematics. We now have what? S is equal to what? U plus V into bracket V minus what? U over 2 times A. That is what? 2A. So this will now give us U times V. That will be what? UV, right? Then U times, we are using this bracket to open, U times V, U times minus U. That will give us what? So this V minus U, okay, U times V, UV, then U times minus U, that is minus what? U square, then V times V, that's plus what? V square, then V times minus U, that is what? Minus what? UV, then everything over what? Over 2A, okay? So all we now need to do is to write what? S will now be equal to what? So let's just rewrite this. We can write it as what? UV minus what? UV, right? Minus U square plus what? V square over what? 2A. Definitely UV and UV cancels out. So this will return what? Minus U square plus V square over 2A, and minus U square plus V square over 2A can also be written as, so we can say that S is equal to what? V square, I just rearrange it, minus what? U square over what? 2A. So we can cross multiply. So if we cross multiply, we are going to be having what? V square minus U square is equal to what? 2A times what? S. So at the end of it, we now have what? V square minus U square is equal to what? 2AS. So we can make V or any of them the subject formula. So we can say V square will now be what? 2AS plus U square. So if we rearrange, then it implies that we have V square is equal to what? U square plus what? 2AS. So this gives us what? Equation what? 4. So these are the four basic or commonly known equation of uniformly accelerated motion. So we can summarize the four equations summarily. We have what v is equal to u plus 8c, that's equation 1. Then we have what s is equal to what u plus v into bracket what t over 2, that's equation 2. Then the third one, we have what s is equal to what ut plus what half what 8t square, that's equation 3. And this last one, we have v square is equal to what u square plus what 2as, and that is what equation 4. So these are the four equation. Of course, you can still expand and get other equation. So but these are the basic the common Lee use equation of uniformly accelerated motion. I want to believe this video has helped someone. Please kindly subscribe to this channel, like, share and comment on this video. And if this video has been of help to you and you wish to support us in whatsoever means, please kindly check the description to see the information on how to go about it. Be looking forward to receiving from you. See you in the next video. Thank you.